All right, welcome to another episode of the Meat Mafia podcast. We're joined here with part two with Nick Norwitz. Nick is doing amazing research with Dave Feldman, and we're excited to have him here to explain some of the stuff that he's working on. Nick, what's going on?
Well, normal stuff. Research, that's cool. Talking with you guys. It's been fun. I could probably say we've just been rolling. We just had our episode 1. It was great to be chatting with you guys, but I guess we're just going to keep rolling to talk about some of the work that me and Dave have been doing, because I'm super pumped about it, around lean mass hyperresponders, lipid energy model. And so I think that's what this part 2 is going to be about, explaining what those are and why I think they're super interesting.
Yeah, maybe a good place to start would just be unpacking some of the terminology there and, putting it into layman's terms, just so, the viewers can all digest what you guys are diving into. Yeah.
So I guess so for me, and we're going to talk about kind of 3 separate papers. One's going to be a cohort paper on what we call lean mass hyperresponders. So I want to start by really defining what that is and why it's so bizarre. Then we have an interesting case report that kind of just highlights one case of a lean mass hyperresponder. And then finally, really excitingly, right now, we've had the lipid energy model paper recently accepted, actually yesterday. So at the point we're talking right now, the paper has not been released. I'm going to ask you to hold this episode until it has been released. But we got some, great collaborators on that, and this is going to be the first formalization of a model that, Dave has kind of had in the works for many years, and I've gotten involved in more recently, and it's going to lay the groundwork for what I think are some incredible experiments to come, and it's gotten the attention of some big names. So I think we're really at the beginning of some really exciting research. But I guess I'll just start rolling.
Love it.
I have a tendency to talk, so please pause me at any point in time to clarify things, because it's probably going to be the things that your listeners are wondering about. But I think the most important thing to start with is defining what is a lean mass hyperresponder. It's the thing that me and Dave are hashtagging over and over again on Twitter, #LMHR. What the heck is a lean mass hyperresponder? A lean mass hyperresponder, by definition, is a person who fulfills just really 3 metabolic criteria on a lipid panel, which is an LDL cholesterol of greater than 200 milligrams per deciliter, which is very high, an HDL cholesterol of greater than 80 milligrams per deciliter, which is also very high, and triglycerides that are very low, less than 70 milligrams per deciliter. So that is the formal definition of a lean mass hyperresponder. Just those 3 cut points: high LDL over 200, high HDL over 80, and low triglycerides under 70. Which might be a little bit confusing because there's no actually incorporation of leanness into the definition. But the first thing to emphasize, that is the definition of a lean mass hyperresponder. Now, how does that relate to leanness and low carb? Well, an important thing to emphasize is that triad of markers is really unusual. Mm-hmm. Because each one is so rare, having them in combination is extremely unlikely, unless they're part of a combination profile in a combination pattern. So, for example, if you look at NHANES, this public database from like 1999 to 2020, if you look at all the people with all the LDL, HDL, and triglyceride levels, 70,310 people. You know how many LMHR there are? 3.
Wow.
There's people that meet those criteria. And so the triad and the definition for lean mass hyperresponders derives from the fact that triad, that formal definition, high LDL over 200, high HDL over 80, low triglycerides under 70, tends to present very particularly in low carb, people eating low carb who are lean and athletic. So if you're overweight or have metabolic dysfunction, type 2 diabetes, and you go low carb, you're very unlikely to manifest this profile. You're very unlikely to see a rise in LDL. Versus, if you're very lean and very athletic, we would guess that if you constrict your carbs, you have a higher probability of manifesting this phenotype. So the leanness of the lean mass hyperresponder derives from the fact that it's people who are lean and metabolically healthy who appear susceptible to manifesting this combination lipid profile. And this is very interesting to me and very provocative, because on the surface, this is kind of counterintuitive, right? If LDL is bad cholesterol, which is still the common notion, then why is it the lean, healthy people, not the obese, metabolically unhealthy people, people with obesity, I should say, that are manifesting this quote unquote unhealthy response? It's kind of a curious initial observation. And what we did in our initial study, which was done under the guidance of Professor David Ludwig at Harvard, very highly respected MD, Ph.D. at Boston Children's Hospital, we looked at data from a cohort of 548 people eating low-carb diets. And what we were able to show is that there indeed is a subset of people who are lean mass hyperresponders, that people manifesting this triad are actually, on the whole, leaner than non-lean mass hyperresponders. So kind of confirming the fact that, yes, this triad does seem particular to these leaner people. And in fact, that across a continuum, and this is really interesting, across a continuum, there is an inverse correlation between BMI and LDL change on a low carbohydrate diet. That means, all things being equal, if you're leaner and you go low carb, your LDL is likely to increase more the leaner you are, in a linear manner, which is really, really interesting. So all things being equal, your BMI is, 20 versus 22 versus 24. The leaner you are, the larger your LDL will increase. That's a really interesting finding, I think.
Yes.
And so, that was kind of the mic drop of our first study, that it's the lean, metabolically healthy people, so the people with lower BMI and actually the people with lower triglyceride to HDL ratio, that those were two of the strongest independent predictors of a large LDL change, were having a low BMI and having low triglycerides and high HDL. That being lean and having good metabolic health markers were the strongest predictors of larger LDL changes, which is just a provocative and interesting finding. And I want to pause there to provide an opportunity to clarify anything that I might have jumped over, because I think some of that can get kind of take for granted how confusing that can be.
Yeah, Nick, how are you guys defining metabolically healthy? What's the benchmark for that?
Yeah, we're using triglyceride to HDL ratio as kind of a proxy. Now that's very incomplete, but given the resources that we had and the biomarkers we're measuring in initial studies, we're kind of defining metabolically healthy as the absence or the counter to markers of metabolic unhealthy, which in metabolic syndrome, the lipid markers of metabolic dysfunction are low HDL and high triglycerides. So the opposite of that tends to be a marker of insulin sensitivity and good metabolic health. So right now, that's kind of the de facto definition. Of course, I'd love a broader set of biomarkers, but when I say metabolically healthy, I'm more referring to the fact of low triglyceride to HDL ratio.
Okay. And you guys, for our audience, there's definitely a lot of different ways to define metabolically healthy. If you were to test, I guess waist circumference is one, kind of more surface level. Are you guys looking at any of those in conjunction with it?
We should.
Yeah.
I wish we could. Right now, to be perfectly candid with you, it's a matter of resources and what we can do. Dave's an engineer and an outsider, and I'm a medical student. We don't have $1 million grants to do these studies. So what we're doing right now is trying to flick down the initial small dominoes so we can get the big wigs involved to do these much more rigorous studies, which absolutely need to be done. So what I want to emphasize is this research is in its infancy.
Right.
And we're trying to use methodology to complement the data we have on hand. So this first study that I described to you, it was, admittedly, and this is a limitation of the study, we had self-reported data that we took from an internet poll. Now, the approach we used, I think, was very complementary to that. We used a hypothesis-naive exploratory analysis so that the computer was actually picking out the points that would say predict larger changes in LDL, and they picked out in a linear fashion BMI. Now, I think it's very unlikely that the 548 participants were able to coordinate in a way that would manifest in this machine learning algorithm decision tree, whatever. So I think that the findings are robust, but right now the quality of data we have, I would say, is not top quality. I'd really love to do those studies, but I don't have the money. So if you know anybody with grant money that would like to support these studies, I'd love to collaborate with them. That's kind of what we're aiming for. We just haven't been able to do it yet.
Got it.
But we have more and more people that are getting interested, especially now that we have the model paper coming together, which I can get into in a minute.
Nick, what were the biggest takeaways from this study that you think the listener should know about?
Yeah, I would say that we found that there was an inverse correlation between BMI and LDL change in a low carbohydrate diet, and triglyceride to HDL ratio and LDL change. So basically, it's the lean and metabolically healthy people that are susceptible to large LDL increases. So the counter to that is, if you're overweight or if you have diabetes, which are major use cases for carbohydrate restriction, you probably should not be that concerned, or you're probably less likely to have large LDL increases, which should be comforting to physicians and patients who might be worried about that. Right now, I think that in standard clinical practice, there's the boogeyman of the LDL increase, that it's thought to be kind of like, oh, this patient might manifest, and we're kind of scared about it, prescribing a ketogenic diet because this might happen. And our literature is actually consistent with a lot of other literature showing that, in the studies that are done with people who have obesity or who are metabolically unhealthy, they might not be susceptible. So I think that, that patient population and clinicians treating that population should be comforted. And the other major takeaway was really characterizing these lean mass hyperresponders, because like I said initially, this is a phenotype that is really weird. This triad of really high LDL, really high HDL, and low triglycerides is something that is under the noses of a lot of lipidologists and clinicians, and I think really underappreciated. And yet there's like a Facebook group of over 8,000 people now who are either LMHR or interested in LMHR. It's something that's becoming more and more popular, and it's a really weird, concerning, interesting phenotype that I think we really have to study for all it could teach us about human lipid dynamics. Like, what's going on? How is it that LDL and HDL rise together as you're leaner on a low carbohydrate diet? And how can we study that to really understand what's going on in human lipid dynamics? It's just a really fascinating phenotype that deserves further study. So this initial study was an observational study, codifying that phenotype and showing that, yeah, lean metabolically healthy people, they're the ones who are likely to experience the large jump in LDL in the context of good metabolic health markers. And then the people that are or have obesity and metabolically unhealthy, they're probably not at risk, which they probably should find comforting.
Nick, is that a good bridge into the second piece of work that you guys are doing?
Yeah. So we'll get to the lipid energy model in a second. The second thing we recently had come out was a case report. It was a clinical vignette published in Frontiers in Endocrinology, just to kind of emphasize some of the key points about what might make a lean mass hyperresponder and what might not. So, and this was a case report of an individual who was very lean and adopted a ketogenic diet that was low in saturated fat. So a lot of people might just jump to the conclusion of, oh, LDL is going up because you go low carb and you eat a lot of saturated fat. That's where everybody's mind goes, or a lot of people's mind go initially, that it's just the saturated fat. Now, I would like to emphasize that if that were the case in the initial study, that would also imply that leaner people are preferentially eating diets higher in saturated fat in a linear manner, which seems unlikely to me. So if you say that it's just a saturated fat, you're also saying that there's a direct relationship between saturated fat and taking leanness, which is a pretty bold proposal. Nevertheless, people make it. So, the title of this case report had to do with the lean mass hyperresponder phenotype presenting in someone eating a very low saturated fat diet. At points, only 17% saturated fat, saturated fat to like 82, 83% unsaturated fat, and yet would still manifest the lean mass hyperresponder phenotype, and a very pronounced one at that. So this individual at peak, the triad was, I think, went from an LDL on a mixed diet of only 95, so very low at baseline, to an LDL of 545, with HDL of 116 and triglycerides of around 40.
Wow.
That's a profound phenotype. I just, like, for people that don't know these numbers, LDL of 545, that's borderline homozygous familial hypercholesterolemia, which is a 1 in a million genetic disease. That's a disease that's like being studied or was studied by Brown and Goldstein. Stories of, little kids developing angina and myocardial infarctions before the age of 10, around the age of 50. This is a severe and debilitating disease, and a 1 in a million genetic condition. And yet we're having someone who's actually on a low saturated fat diet without any reasonable genetic findings, manifesting this in a manner that's basically determined by his macronutrient composition, by being carbohydrate restricted and being lean. And other things we demonstrated in this study, or at least in this case report, were that the LDL did seem to be strongly associated with BMI. So for example, as the BMI came up in this individual, which it did over time, the LDL dropped. So BMI kind of creeped up. It was around 18.7 to 18.8, and ended up going around to like 19.6 to 20.2. As it came up, the LDL dropped correspondingly. And that happened even despite, in the last measure, we had various lipid time points, despite an increase in saturated fat.
Wow.
When you're kind of like tacking these things against each other, you're at this like one time point where you have a very low saturated fat diet, low cholesterol diet. In fact, the cholesterol intake was the lowest at the point where LDL was the highest. So at the point where LDL was 545, cholesterol intake was low. Saturated fat intake was like 17% of fat intake, where it was 83% monounsaturated, polyunsaturated fat intake. Yet BMI comes up, LDL drops by well over 100. And at the last time point, saturated fat intake was much higher. This was done experimentally, but it was like 45% as opposed to 18. And yet the LDL was still much lower. So, if you kind of put the basic equation together, you have somebody who goes low carb, is very lean, their LDL shoots up as part of this lean mass hyperresponder triad: high LDL, high HDL, low triglycerides. And as they gain weight, BMI goes up, LDL comes down, even though saturated fat is going up. So BMI increase, saturated fat increase, you add those things up, what happens? The net effect is actually a drop in LDL, which is kind of provocative and interesting. It's suggesting, or consistent with the idea, that in this phenotype, BMI dominates over saturated fat intake, that it's not the standard, the common knowledge that it's saturated fat driving the phenotype. This phenotype can present in a low saturated fat context and varies inversely with BMI. So it was shown longitudinally in this individual and just provided a pretty strong clinical vignette of the phenotype we're seeing in this broader population that we described in the first study of over 500 people. Just kind of really emphasize the point of just how extreme this phenotype can be. The fact that it can happen in the absence of genetic findings. We did a very extensive genetic workup, and it was very clean. In fact, all the risk factors were primarily those that would contradict the phenotype. So, for example, there were markers that were risks for low HDL and high triglycerides, and yet the HDL was 118 and the triglycerides were 47. So it's ironic, but it's really showing that it is the dietary environment that's driving this phenotype, which is quite interesting and consistent with the prior data. So this is just kind of a provocative N=1 showing what this is really weird.
Yeah.
Nothing at present that can explain what could possibly be going on with this person. Just kind of like, poking that question of like, why is this going on? What's going on with the lipids? What's driving this?
So Nick, with someone like that, LDL skyrocketing high, 545, all other indicators are that they're metabolically healthy. Is that number still something that they should be worried about?
I would say at present, absolutely.
Yeah.
We do not have any data showing that anything but high LDL is dangerous.
Mm-hmm.
That's not the same as saying I'm sure high LDL is dangerous, but the preponderance of data at this point would be saying high LDL is always going to increase risk.
Mm-hmm.
That said, I would argue that the lean mass hyperresponder group is very particular as opposed to other conditions of high LDL. Because other conditions of high LDL, especially a high LDL that high, are going to be due to underlying dysfunction in lipid metabolism. So, the direct comparison is familial hypercholesterolemia, even homozygous familial hypercholesterolemia, in which you have a mutation in various receptors, LDL receptor, ApoB, PCSK9, but you do have a dysfunction in underlying lipid metabolism and a break of the normal negative feedback. And that's very different, or one could propose that that's different than a metabolic response to a macronutrient shift. So in this individual, there is not high baseline LDL. Baseline LDL on a mixed diet is 95. You don't have that in familial hypercholesterolemia. This is not being driven by an adverse response to saturated fat, clearly. This is a macronutrient shift. So the body's adapting somehow. And that's, a very different condition. It's readily reversible. Again, there's no genetic driver. So if this is a metabolic response, it's plausible that the consequences are different. It doesn't mean that's the case. But right now, I would actually say that, studying LMHR and studying plaque progression in this population would be the strongest case for assessing the lipid heart hypothesis. Because at present, we don't really have a population in whom there are no other risk factors and in whom LDL is just isolated high, no other problems. So you have people who are metabolically unhealthy. So a lot of people are metabolically unhealthy. If you do population level studies, there's going to be a correlation between high LDL and poor cardiovascular outcomes. That's in the context of metabolic dysfunction. You have epidemiological studies showing that there's a correlation, but even in Mendelian randomization trials, which try to, isolate LDL as a variable, the variation is still being driven by genetics, underlying genetic variation, not by environmental change and a metabolic response, which I would argue is potentially a very different thing. And then again, the main comparison is familial hypercholesterolemia, which is a genetic defect, not a apparently metabolic response in these individuals. So we don't have any other context in humans where there isn't an underlying genetic driver and people are completely metabolically healthy. So it really does isolate this high LDL variant. And if we do a study and plaque is progressing rapidly in LMHR, that's probably the strongest proof in support at present, and in my opinion, of the lipid heart hypothesis. It really provides really strong evidence. If I saw that to be the case, I'd be like, okay, this provides a good proof of principle that high ApoB alone is sufficient, not necessary, but sufficient to drive atherosclerosis. Versus if we find out that's not the case, that's probably an even more provocative finding. Because if there's even one case, one scenario, even if it's a very unique subset of people, where you can have very high ApoB, very high LDL, and have very low or slow progression, that means we really do need to rethink or evolve the standard lipid heart hypothesis. So irrespective of how the risk data fall, this population provides a really interesting, unique opportunity to kind of explore the conventional wisdom around what drives cardiovascular disease. And fortunately, that study, or at least one study that's going to start to examine that question, is already underway out of the Lundquist Institute at UCLA, where we're actually following plaque progression. When I say we, I don't mean me, I mean another group that Dave has fundraised for. We're prospectively following plaque progression in 100 lean mass hyperresponders.
Mm.
See if there is progression. Now, I will say, and I haven't said this at this point, we did do a coronary CT angiography on the patient in this study. The reason that was done, I want to clarify, was not to provide an excuse for not medicating this patient. It was to explore, over a time span of 2.5+ years. This patient's had LDL 400, 500 plus. Presumably there could be, or theoretically there could be, some plaque progression. It was unclear. So the patient wanted, hard functional data to decide whether or not they would go on medication at this point. CCTAs now are very advanced. They can pick up very small amounts of plaque. So over the course of 2.5 years, you might, a priori expect to see some plaque progression. There are not a lot of comparator data, but for example, like you can see plaque progression in very, very young children with familial hypercholesterolemia, similar levels. And we actually did do a compare and contrast to a case of familial hypercholesterolemia. I'll give you the video abstract in the paper to link. But when we did the CCTA, the coronary CT angiography, it was perfectly clear. Now, I'm not an expert in CCTA, but we did make sure to have 3 independent cardiovascular imaging specialists look at the scan. And I will say all were relatively surprised that it was so clear. This is just an N=1. I don't want people to extrapolate beyond that. But for clinical purposes, we did order the scan. And in this single individual, there was no finding. So I don't want people to take that beyond, but we did order a scan of this individual, and it was clear. So I'll be really interested to see what the data are on the larger cohort.
Yeah. So Nick, would that be the second stage for you guys in terms of the research you guys are doing? Would that be looking at some of the calcification and that plaque information, some of those scans?
Well, I think there are kind of 2 prongs going forward. One is assessment of risk, studying this population clinically, seeing is there plaque progression, so people know how to, manage this population, or have at least more data upon which to base clinical decision making, and patients have more data. That's one set. The other set, which I find very interesting as an academic, is just exploring the mechanism. Because this is such a weird thing. We don't have any genetic explanation for how you could manifest this triad of high LDL, high HDL, and low triglycerides, and have LDL change on a low carb diet with an inverse association with BMI. Like, how can you possibly explain that? That is so weird. I know a lot of people listening might not be lipidologists, but if you talk to a doctor, ask them, how do you possibly explain that phenomenon? It is mind-boggling.
Right.
And really interesting. And so I think the other aspect of this is starting to unpack what might be the mechanism driving this phenotype. And that is what the lipid energy model is. The paper we just had accepted. And I'm super excited about it. I know we're not going to have the time in this episode to go into depth with it, but by the time it's released, I think my colleague Dave is going to have an amazing video abstract on it. His last video abstract on the case report now has 55,000 views, and I know this video abstract is going to be amazing, and we'll have the paper out so you can read it for yourself. But I'll give the short pitch on that, just the basic mechanism, and we can come back and dig into the details. But the basic idea is as follows: that when you're lean and carbohydrate restricted, your body has a greater dependence on fat as a metabolic substrate, right? And so what happens is that there is a shift in the hormonal milieu. Your insulin drops, your leptin drops, that's a hormone released from fat, and there's an increase in release of free fatty acids from your fat cells. Some of this directly fuels your muscle tissue, but a lot of the free fatty acids that are circulating around get taken up by your liver. And then they get repackaged, this is proposed by the model, into triglycerides, which is a glycerol backbone with free fatty acids. It's how fat is stored. They get packaged into these molecules called VLDL, very low density lipoproteins, and shipped out of your liver. VLDL is the precursor to LDL. So what happens, say in the fasted state, is VLDL go out. They're carrying fat fuel, triglycerides. They're carrying it to fat cells to replenish the fat cells and to oxidative tissue, your heart and your skeletal muscles to fuel them. And then what happens is you have these big fat VLDL carrying triglyceride fuel. A protein called lipoprotein lipase liberates the triglycerides, turns them back into free fatty acids, which go into the fat cells, go into the oxidative tissue. And then this big VLDL particle, the one that was sent out from your liver carrying the triglycerides, as it's depleted of the triglycerides, as the triglycerides go down, it shrinks and becomes an LDL particle. They're all part of the same lineage. And as it does so, that turning over process of LPL liberating the triglycerides, pulling them off to go into fat tissue, to go into muscle tissue, to go into heart tissue, the surface remnants of that particle, as you can imagine, it's getting smaller, and you kind of have to have little surface remnants flubbing off as the volume decreases, the surface area decreases. That's actually picked up by HDL. So at the surface, there's a lot of cholesterol, phospholipids, apolipoproteins that are being transferred to HDL particles that suck them up. So the VLDL shrinks into an LDL. As the triglycerides are broken down, fatty acids go into tissue, and then the surface remnants are picked up by HDL. And so what you can see there, the net effect of this turnover process is that you get more LDL, you have low triglycerides because the VLDL have shrunk as they give off triglycerides, making LDL, and then the surface remnants are taken up by HDL. So what do you get? A triad of high HDL, high LDL, and low triglycerides. So really the thing that's driving this triad, or we'd hypothesize is driving this triad, is increased secretion of these VLDL particles carrying triglycerides from the liver as kind of delivery trucks carrying the triglycerides area around the body, and combined with high lipoprotein lipase mediated turnover peripherally. So I'll repeat that again. High VLDL export from the liver combined with high lipoprotein lipase mediated turnover of these VLDLs manifests in high HDL, high LDL, and low triglycerides. That's kind of the triad. And the model will propose that the triad's going to change or become more extreme given, manipulations and variables that would require, say, greater energy output. So just increasing aerobic energy output or decreasing carbohydrates or being more lean. All of these things are levers you could pull to presumably change the extremeness of the triad, specifically how high LDL and how high HDL are. And that's kind of what we're starting to see more consistent with the cohort data. That's why when you have this individual who gains weight, the triad becomes less intense, or you lose weight, the triad becomes more intense. It provides a very useful framework for hypothesis testing. And in this paper, we actually provide a wish list of key studies we really want done to evaluate this model. But we put forward in this paper, kind of the model to explain the phenotype that's going on and set the directions and priorities for future studies to evaluate it. And I encourage people to give it a read. I will just plug, it really helps if people, download it, watch the video abstract. Downloads help, sharing it helps. And what's been really uplifting to me is to see the response of, the kind of the big wigs and the luminaries in the field. We've shopped this around a lot. And I was kind of worried, like, this is a bold hypothesis. This is an extreme concept that, people will kind of be like, no, this is ridiculous. I'm going to, you completely missed this thing, which is a very real possibility. A lot of lipidologists have been doing this longer than I've been on this planet. And yet when we go to, some of the, when I shop this around professors at Harvard, or we send it to, some of our co-authors or now co-authors, Matthew Budoff, who has like 1,200 papers, world-renowned lipidologist, or Anatole Cantouche, he's at INSERM in France, author of my favorite lipidology paper of all time on the reverse remnant cholesterol transport theory. It was in Cell Metabolism 2020. Somebody I've forever respected. We showed it to him. He got really excited about it. We've shopped it around a lot of people, and people are like, there's actually probably something to this, or at least it's a provoking hypothesis that deserves further study. So we finally formulated it, and that's kind of the core concept.
Yeah.
maybe we can come back and talk about the specifics of what's regulating that and all the little questions that might arise, like why is it more extreme in lean people? Why can you reverse it with, you know, relatively moderate carbohydrates? There's a ton of nuance that I'm not getting into here, especially the regulators, but it's a big picture of the lipid energy model, which is explaining the lean mass hyperresponder phenomenon. What can I clarify? This is such a mind-boggling thing. It's really hard to get the first time. So I apologize if everything I just said was just word salad. I never know really where to start with these concepts. Dave is a lot more charismatic and better at explaining this verbally. We kind of made a deal that I can be the pen and do the writing, and he can be the voice. So I'm breaking that contract right now, but I'm giving it my best go. So please, what can I clarify? What have I said that is utterly confusing?
No, I don't think anything's incredibly confusing. It sounds like it's an amazing step in the right direction. And I know that we've obviously had Dave on before and have a tremendous amount of respect for him. I think what would be awesome would be to do another round with both of you guys on over the next couple of weeks to actually talk through the 3 studies and papers that you just talked about, because it sounds like it's going to be very well received within the community, and it's an amazing step in the right direction, especially for all those people that are, you know, that are afraid to maybe make that journey towards a lower carb approach because they've just been told for decades that they need to be worried about their LDL. So the more that you can demystify that and give people actual science and help them make informed decisions, it sounds like it's just incredibly applicable. And I can't wait to watch some of the video excerpts myself. And we want to make sure that, you know, we link to all 3 of those pieces in the show notes so that for anyone that's listening, they can actually go back and do some of their own research on it as well.
Yeah. No, thank you so much. And I hope people found this is intellectually provocative. What I do want to emphasize, because this so gets lost in social media and I take hell for it, maybe appropriately so. But the lipid energy model, what I'm explaining, if I haven't made this clear, this is not saying by any means, oh, this is why, and therefore your LDL is fine. I could be dead wrong in everything. I could be right on the model. We could be right in the model, and it could still be killing you. Mm-hmm. Only a mechanistic explanation, which I think really deserves further study for what it could teach us about human metabolism. But I think it's appropriate for individuals to still be concerned given where the data is. I don't want people to have, you know, a false sense. The last thing I want is to do harm to anybody. And I feel like the conversation does get very muddied on Twitter. It's like or social media, because it ends up being a game of telephone where I say something, then somebody gives their interpretation of it, and somebody else gives their interpretation of it, and suddenly it's, you know, Nick says high LDL is fine, your high LDL is fine. I've spent more time than you possibly could imagine coaching people on how to lower their LDL, who are lean mass hyperresponders. Right. It's not something that I take lightly. I am not sure that it's harmful. I am not sure that it's not harmful, but I'm still of the opinion that it's appropriate to be conservative about it. And that if you have the flexibility to go low-ish carb without being keto, if you can do 130 grams of carbs a day and have your LDL at 90 versus doing 20 grams of carbs a day and have your LDL at 545 and all other things being equal, I'd still do that at this point in time. I want to study this because I think it's interesting, because some people don't have the flexibility to go off a ketogenic diet. So they're trading between, like, you know, having higher LDL or having more seizures. There's some people for who this is really a concern. And I think that, you know, the study of this phenomenon can teach us so much about lipidology in general and advance the field of knowledge. But this is not a proven concept, and it's not an explanation for high LDL being benign. It's an intellectually fascinating phenomenon. And I really would love, if I could ask one thing of people listening, as if we could come together in a respectful concern and discussion and intellectual curiosity around this, without being dogmatic about the principles of risk, and, you know, approaching this with the appropriate caution. Because unfortunately, what I do see is people try to divide into camps. There's a lot of polarization, and to be perfectly honest, that hinders the research. Because if we get a taint of, you know, you're provoking people to engage in a dangerous lifestyle, that makes it really hard to pursue this academically. And I think this is very important to pursue academically for what it could teach us. But I'm by no means attached to the outcome. I just want to put together a genuine hypothesis and evaluate it. And if it's wrong, I've learned something. And if it's right, I've learned something too. But I just want to be like together in respectful concern for, this is a clinically serious situation. And unfortunately, no matter how many times I say that, there's still somebody in a YouTube video say, "Oh, great, I was so concerned about my LDL. Now I don't have to be concerned."
Right.
I didn't say that.
That wasn't the point.
Yeah, that wasn't the point. And again, I'm also not saying that I know your high LDL is bad. I'm just saying like, this is an area where we have to say, we don't know what we don't know. This is interesting. So all my enthusiasm comes from the fact that I am intellectually curious about that. That is all. And I hope people can join me in that, in being curious in what we don't know about lipids and carbohydrate restriction. So I want to emphasize that. And even though I have, I'm sure that it's not going to land completely, but as much as I can, I'd like to. So yeah, please check out the video abstract. Please check out the paper. Please give your comments and thoughts. We really want this to be an open discussion. I think something that our team takes a lot of pride in is trying, I'm not as good as Dave, but trying to make this accessible to all levels, to engage high-end academicians, Harvard, Oxford, Stanford, elsewhere, at the same time trying to make this somewhat digestible to lay audiences so that we can engage people in science and get people interested in citizen science. So that's why I so appreciate Dave and honestly a lot of people on Twitter, you guys, in fact, for like, being willing to have these discussions so that we can try to make knowledge accessible to everybody, because this is really relevant to everybody and everybody should be part of the discussion.
Yeah, couldn't agree more. And I think having Dave on previously was just really enlightening. And I think he taught us a lot about what you guys are working on. And this is just a continuation of the great work you guys are doing. So, we'll link to everything in the show notes. I think this will be a good like precursor episode for people to familiarize yourself with what you guys are doing. And then hopefully once everything's out there and ready to go, we can have another conversation with you and Dave and really unpack some of the stuff in more detail.
Yeah, I'm excited. Please do hold this for the release. Right now, everything's very DL. Dave's actually this weekend's a Metabolic Health Summit. He has like the papers printed out. I sent him the PDFs. He's printed them out, like folded them up, labeled them top secret. He's handing them out to people like low key, handing it off the set and whatever. So right now it's on the DL, but hopefully.
When will it be kind of ready to go?
I think next, around the 17th will be the release. So I have the final author's proof that I've kind of copied. Dave just hasn't started the video abstract. He's our video abstract guy. So we're aiming for a tandem release on that. Cool. And if the journal will hold the release until then we're going to aim for probably around the 17th. But it'll be out later this month.
Awesome.
And so everything, the pump is primed.
Perfect.
And I do think it's going to be a very provocative discussion on social. So hopefully people can engage in the discussion and think critically. Try not to take little Twitter excerpts. People
Absolutely.
take shots of suggestions and digestions. And anyway, the message should not be simplified because this is not a simple topic. So I really appreciate the time anybody's taken and listening to this or trying to think about this critically, because it's pretty cool. And if you're, trying to engage in the science honestly, then all respect to you.
Absolutely. Well, Nick, this is great, man. Thank you so much for coming back on, and obviously looking forward to doing this again soon and all the amazing work that you're putting together. It's incredibly impressive. We have more hope with people like you in the medical community, and just really looking forward to seeing everything that you and Dave go on to accomplish.
Fantastic. I have one final question. Harry/Clemenza, I asked you at the beginning of episode 1. It was 2 hours ago. You know what I asked you? What was going to be my
so you needed a Meat Mafia name, and I think I'm going to go with Vinny Cardoni.
Vinny Cardoni.
Okay. No, I need to come up with a legitimate name from the Godfather. I'm gonna have to do a little bit more research because both Clemenza and Sollozzo are Godfather characters.
Yeah, and do a Twitter
I
launch of
honestly
it.
haven't seen The Godfather. I don't know if that's terrible.
Yeah,
Wow.
you need to
All
correct
right.
it.
We're gonna postpone your christening into the Meat Mafia until you watch that.
Okay. Alrighty. Maybe with the release of the podcast, we can
Yeah.
reveal what the name is.
No, that's perfect. That's perfect. We'll it'll be well, actually, we don't want to take any light away from what you guys are posting, so maybe we'll do it like the day before.
Yep. Yeah.
Okay. All right.
Awesome. Well,
I love
thanks
it.
so much, Nick. We really appreciate it. All right.
Thanks, Nick.
All right.
Bye.
Bye.